Hello everyone, welcome back to Sat385. Okay, so last time we did the practice lab assignment, and this time we'll go over the practice quiz. Here you can see we are at our landing page for the website, fa24.stat385.org. Okay, we can use this link to navigate to current week, or we can just go to week one. Here's where we're at. Here's the week one page, welcome and syllabus. And we did the lab assignment last time. Now we're gonna do the quiz. Okay, let me just close these, don't need those open anymore. All right, so let's open this up. Go to actually, I'm gonna change this to student view. Okay, so nothing is appearing for students right now because I'm still recording these videos before the semester has started. Okay, so now this is with student access. Okay, quiz, get familiar. All right. Okay, so right at the top of this quiz prompt is this link back to our quiz policy document. So let's just go over it again because quizzes are more complicated than labs and more important. Okay, so right, there'll be a total of 8 quizzes in Sat385 administered through Prairie Learn. Great. We're on Prairie Learn right now. Awesome. Okay. Quizzes will be low stakes, unlimited attempts. So you can keep submitting. Each time there's going to be no penalty for submitting incorrect answers, and your score can only go up. So if you got something right, got some partial credit, got some of it right, and then you submitted again and got that part wrong, it's not going to say like, oh, now that's wrong, and your score goes down. No quizzes will be dropped. I know students are not going to like this. However, there will be opportunity to earn buffer points with each quiz. And the way that this is going to operate is it won't function as extra credit. So like you can't keep accumulating these buffer points over the entire semester to get your grade above 100%, but you can put some points into like bank if you like, and then you can withdraw from them to maintain a higher grade. So for an example, if you and you get these buffer points by completing a quiz 100% by the first due date. So if I go back to the syllabus here, okay, and go all the way down to this deadline. So on Thursday, September 12th, quiz 1 will be due. And I think that's the due date, or that's the due date. If you complete it by that date with 100% completion, that's when you get your buffer points. If I go back to the quiz policy, oh yeah, it's right here too. What am I doing? Right, so 105% credit for Thursday, December 12th, and then 100% credit the following week. So you have time to do this, but these will keep coming in. So that's why, again, it's good to build buffer points, especially with these first few quizzes. Technically speaking, the quiz we're going to go over is just practice with the Prairie Learn system and practice with the types of questions you'll be asked and how to do them. But anyways, so if there's 8 quizzes, if you on the first 4 complete 100% correct by each of these deadlines, then you will instead earn 105 points. So then if you complete the remaining quizzes at 95, the 5 points you earned as buffer points will cancel out the 5 points you lost, and so that your quiz grade would be 100%. You'll get all 40 points for this class for quizzes. If you do all the quizzes early, complete all of them, you won't get 105%. You'll still get 100%. But it's a part. I think it's good to stay organized, stay on top of it, and as this course will progress, the content will keep coming in, and so it may not seem like it now, but it's easy to get behind if you haven't built a good foundation. Most people, I would say, are on it and build that good foundation, and this course is an enjoyable experience. I know that there's a lot of moving parts in this asynchronous environment, but we'll stay on it, stay organized, and if you do it, then build your buffer points and build your base, and then as the semester progresses, you'll have some cushion. Okay. Right. Unless otherwise specified, so you cannot load any. Okay, so this is not. We'll go over this a little bit in this video, I think, but it's not something that's immediately relevant. Okay. tips and tricks. Before submitting to the autograder, you should run your code locally and verify that it produces the expected output. You may want to do this like almost like painfully so, like doing this with like even simple stuff just to make sure. Getting in that habit will be a time saver, because the questions we will ask in the quizzes as the semester progresses will get more and more tedious, and so you want to gain your practice this, even though it seems at the start that it will be very obvious. If you are asked to write a function, you should test it locally by supplying potential values for each argument. Same thing as the above. You're just going to want to do that. It may seem like it with easy functions that they just work, and you can work with the Prairie Learn environment directly and just submit it there. But every single time, there's unlimited attempts. You'll get timed out for a minute. So if you do a little typo, then you'll have to wait a minute to resubmit. So that can be frustrating. Oh, and that is actually kind of the third point. So we do not recommend editing code directly in Prairie Learn. Let's go to Prairie Learn just 1 second just to see what I mean. Nope, wrong one. This one. So here's like a Prairie Learn environment that kind of mimics what an R environment looks like, but it doesn't have, you can't run code here. You can just supply it. So this is what we mean by don't edit your code directly in Prairie Learn. It's highly recommended that you edit your code using a proper text editor, such as the one included in RStudio. Yeah. And then something to keep in mind, I know this would make more sense as the semester goes, but unless the question notes otherwise, you do not need to defend against improper input to your function. So for instance, if like we ask for somebody to supply a numeric object, something like that number 3, that's an argument input that somebody could supply the character C. In which case, if your code is expecting a number, supplying it with a character is going to just break something internally. And really professional code will defend against that. Will return an error message up front, or a warning, it will provide a descriptive error message to say you've supplied a character vector, or you supplied an object top that wasn't numeric. It will just kill the code and tell the user what happened. At this stage, we don't need to do that. We're not going to be like antagonists here with the questions that we've written as you're learning. Unless otherwise noted, but that's going to be something where like you'll have the opportunity to see clearly what is being asked. We're not just going to like say, whoops, you input it didn't guard against character. We're not going to be annoying with this. Okay. All right. So that being said, so that's the quiz policy. Let's go back. And okay, so this is actually good. This block of questions here will go over the syllabus. So you get practice with Prairie Learn, learn the course syllabus. This is great. So you've got mail. Which of the following are acceptable email subjects when emailing the course staff? Read the syllabus to find out. Well, okay, so stats 385, nope. Okay, so I get a lot of emails, and so I'm gonna have filters up, and so I want stat all caps 380 space 385. And I know this seems pedantic and silly, but like it in the course catalog, it is stat all caps space 385. So there is some method to the madness here. And I get a lot of emails. I want to be able to respond to your issues in a timely and efficient manner. And so I want to be able to see them. So make sure that you follow these conventions so I actually get your emails. Okay. So stat 385 space. Okay. So this is stats. Nope. This is lowercase. Nope. Stat 385 lab 3 regrade request. Okay. This one doesn't have a space there. I think that looks correct. Login issue. Exam scheduling issue. Okay. Good. Got it. 100%. Good. Okay. Just to see, if I were to do this, oh, that's right. I got a minute to wait. Well, I got all the points. I'm going to go back and, okay, next question. Yeah, leave page is fine. Which of the following technologies will be used in the course? Python, no. Piazza, no. Ed, that's our discussion forum. RStudio. Prairie Learner. Compass, no. I think we use Canvas, right, for emails? Okay. Got it. Nice. Next question. Which of the following is the discussion forums used in this class? Should be are the discussion forums used in the class. It's kind of the bad grammar in this question is actually serving as a hint to what the answer is. It's like we're trying to say like, hey, there could be more than one, but however we've grammatically confused it because there is actually only one. Anyways, Ed. Okay. Good. I have read the syllabus. Although I'm going to say that and I'm going to mess up one of these. I just know it. That's how. Okay. Who is the teaching assistant for this course? Here we go. There's one TA. I will have several staff to help with exams, but there's only one official TA. Okay. Sarah used to be Demetrios' last semester. I know Rajdeep is, and then all of these people also last semester or previous semesters. It's just Rajdeep. Great. We are doing well. Who is the instructor of this course? It's me. Daniel Eck. Okay, it's kind of funny. All right, so that's okay. If I just go back, I could just hit. I would normally just go on to the next one, right, and just kind of just get this all done. But I just want to point out that these were all just sort of 1 point, select the right item type questions. Now we're going on to 4 point questions where there's going to be some R-based type questions. Okay, so here we go. All right, so a little bit more complicated. I'm going to read this carefully, a little bit slowly. So the following will help you become familiar with writing code and objects. And the reason why I'm going to read this carefully and slowly is because, R is very specific. Like you can't mix up capitalizations. You have to spell things completely correctly. The stuff that we're going to ask you to do, it's very easy to mix up. So like we're trying to be as clear as possible with these instructions, but there may be some tricks and you may need to actually read it clearly. I know that even when teaching this class, sometimes if I slip up and I go a little bit too fast, I'm submitting things to the auto grader and I'm like, my code works. It works, but then it didn't actually follow the prompt. And so you do want to get in the practice of reading these. Okay. So help you become familiar with writing code that creates objects or checked by our auto grader. So objects are something we're going to talk about next week. Objects and functions. So this won't do much to you right now. This is just getting used to what R will be. Mostly getting used to the Prairie Learn system, but the kinds of the things that we will, use the Prairie Learn system for. Okay, so create 3 objects in R named A, B, and C respectively. We're not going to go over objects right now, but it's going to be kind of, straightforward to see what they are, at least at a conceptual level. Okay, so we want to create an object A, which is an integer vector of the integers from 1 to 100. List all the numbers, 1, 2, 3 integers, all the way up to 100. B, a character vector. First element should be hello world. And second element should be welcome to Stat 385. And then C, another character vector containing the letters of the alphabet from A to Z. 1 letter per element in all lowercase. 26 letters, there's going to be 26 elements in order, A, B, C, so on. Okay, so you can see here that, or in the above, that you had a character vector, but each element consisted of more letters, and then this one is 1 letter per element. Okay, so how do I do these things? Well, we don't know, except the following code solves this question. Great. So I understand you could just copy this directly into the browser, or sorry, into the editor. Let's just open up R, get organized again. Okay, I am in RStudio, right? I'm actually in my project right now. I actually don't like that. I do want to be in my project, but I want to. Okay, so let's just say that I'm not in my project. Okay, now I'm just in the base R session. Now I want to go open my project. I can go here, open project. It is on my desktop, my stat385 directory, and there it is. Okay, open. Okay, so now it's going to switch to this project. So it's the same thing. It's R Studio. It's going to run R. And however, I'm just in my project. So you can see all the things I have here. Okay, so this is just a simple copy paste job. So I don't think I'm going to create a new file for this, but I do want to play around with it. So I did Control-Shift-N to create a new editor here. And let's just see what happens. So you can see I run it, the code, that was command return. Alternatively, you could just copy and paste, but command return works on my machine. There's also similar keyboard shortcuts for Windows machines, and yeah. Okay, so then, I've run this code, and you can see here in my global environment, I do have an integer vector with 100 elements. We can, print it out. You can see it. Element 1 is 1, element 17 is 17, so forth and so on. B was my character string, or character vector. It's got those 2 elements, and C is all the letters. Okay, so yeah. So this is it is gonna run and do, at a conceptual level, the right thing. Delete this comment and place your code here. Okay, save and grade. I know, it's so... Is it right? Okay. I know, it's like, even though it's a literally copy paste, I'm just like, I'm just worried something will go wrong. But it doesn't. So that's good. So then you can see here, even with this simple task, create these objects, when we sort of have an intuitive understanding of what this is going to involve, there's still a lot of room for partial credit. And I think this is a great example of this, to say that, I think that there's some natural hesitancy to auto grading systems from both students and instructors about how do you actually do this in a way where people can learn via understanding little errors that they make, rather than being all or nothing. And we've done a lot of work to build in partial credit and descriptive feedback, so that you can actually see what's going on with your answers. Here we got everything right, but you can go through this and see it. Is the code free of illegal functions, code, and packages? That was that thing in the quiz policy document. We're not calling outside sources. Does code run without errors? Do these objects have the correct lengths? Are they the right types? So forth and so on. Okay. So anyways, we got all the points. This, again, lengths, types, and all that stuff would be more helpful to you in the not too distant future, when we cover objects and functions in more detail. Okay, so for now, did it. Okay, so a slightly more involved task in this. For this exercise, you will write a function to calculate the area of a circle, which will help you become familiar with writing functions that are evaluated by the R autograder. Write a function. So, okay. I think this is the 7th question in the lab. Okay, I'm going to go to RStudio. Delete this. And I'm just going to save this as, I don't know, maybe that. Quiz 0. Okay, so I have a script here. Okay, good. So, calc area. So I want to, okay, what's it say? Write a function named this. If something is given a specific name, I'm just going to not think about it, copy it instantly, and put it where it needs to be. I think I overkilled the idea with this by creating a new .r file, but nonetheless, that's just what we're going to do. Okay, so it's a function with one argument, radius, a length 1 numeric vector. The function should return a length 1 numeric vector. It stores the area of a circle with radius being the variable name, the argument given to this function. So recall the formula for the area of a circle, pi r squared. Okay, so this this is key, and this is, reading the entire thing, because we're just going to demonstrate a point here about, giving partial credit. Okay, so while 3.14 is a rough approximation of pi, it will not be good enough here. Type and run the command pi in R. You may find this useful. Okay, so let's just, I want to do 3.14 times radius squared. Yeah, and then radius equals, we'll just try that simple. Okay, that worked. Okay, 4 times 3.14, 12.5. I think that's the right thing. Okay, great. Okay, so now, let's clear R, clear this, just because I don't want it to reference quantities that are in that environment. More on that later. Equals function radius. Okay, this. And I'm just going to say, just to designate that where you're going to return this quantity. You don't technically need to include return. You can just have the last line of the code is what gets run and outputted, but it's sometimes better to specify, especially at this point in the class. Okay. All right, so let's try it out. Okay, little trick here. So I have my function. Actually, we can go into this later. Radius equals 1, 3.4, 2, 12. Okay, so the function is clearly working and doing the right thing with respect to this 3.14 input. Function works, not returning errors. It's doing the right thing. It's multiplying radius, whatever is supplied, and running it into this equation. It's just we're using 3.14 instead of pi. Okay, so I'm pretty confident that this will work with 3.14. Okay, let's see. Code free of illegal functions, code and packages. Great, I get a point. Does code run without errors? Great. However, I'm missing points. I have code that worked. We saw that it worked. It worked in all the configurations that's on our end that we are supplying, including return with a random radius. But it's not returning the right values. It's the correct object return. So I'm sure that we are well aware of the number or symbol pi. Yeah, the number pi. And so you can actually see that this is a quantity that is built in to R. When you download R, you will have access to this. So pi is not 3.14. We know that. It's an infinite string of numbers, right? And so here, we run pi into R, and we can see the first few numbers, that's the first few decimals. There's actually more. R has more decimals associated with pi. It's just the print method only displays these first 6. Anyways, it's an important quantity for mathematics, for statistics, so it's built into our programming language, and it's given the name pi. So we don't need to use an approximation. We can use the number itself. Okay, hopefully that me rambling was more than a minute, and then we can run it again. Okay, so now with pi supplied, I get the right stuff, and I'm done. Okay, so right. It's important to read the questions, and there is a difference between code that runs and code that code that runs and is basically doing the right thing, and code that runs and does exactly the right thing. And sometimes you have to read these things carefully to know what to do. Okay, that's the quiz. Thank you, and I will see you next week. All right, enjoy transitioning to the semester. We have some time. If I go back here, just let me end. Okay, so these practice labs are due by Thursday, September 5th. They're not going to count for your grade or against your grade or anything like that. It's just more, we've built in the Prairie Learn functionality so that you can play with it in a completely, sort of playful environment so that you can get used to it. And then next week we'll have labs, and there'll still be time. Oops, I haven't booked the page. That's right. So it's not there. But we do have the outline. They'll be due on the September 12th. So there's time. Okay. Videos here. More videos from David Dalpiez. I would recommend watching them. Yeah. All right. Take care. See you next week. Bye.